In this video, we'll talk about how to find the equation of an ellipse given the foci and the major axis length. So recall that an ellipse has the following equation: x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And remember, the a squared and the b squared can be interchangeable depending on whether the ellipse is vertical or horizontal. So if the ellipse is vertical like this, then the a squared will be written under the y term. But if an ellipse is horizontal like this, then the a squared is written under the x term. So keep that in mind. So let's work through a couple examples. Let's check out this first one. We're told that the foci of some ellipse are located at negative 2, 0 and 2, 0. And we're told that the major axis length is 8. So let's make a quick sketch to visualize this situation. So the foci are 2, 0, 1, 2, and negative 2, 0, 1, 2. So we're told that the major axis length is 8. So what that means is the major axis runs from one vertex to the other vertex. So in this example, we're told that the foci fall along this x-axis. So the ellipse is going to be shaped something like this. And we don't know what these vertex points are, but we know that the total distance between them must be 8. So it helps if we can first identify what is the center of this ellipse. So the center will be directly in between the two foci. So we can see that that would be at the point 0, 0. So the center is 0, 0. And when we write an ellipse and using this form, the center will have the coordinates of h, k. Now the a is the distance from the center to each vertex. So we can see that if the total distance from one vertex to the other is 8, then the distance from the center to one vertex must be half of 8. In other words, this distance must be 4, and this distance must be 4, in order for these two to add up to 8, which is the total length of this major axis. So A is equal to 4. And now we just need to figure out, well, what is B? Well, B is the distance from the center to the co-vertices. So the co-vertices, recall, are right here and right here. So this distance B, we don't know B, but we do know that this relationship exists. C squared is equal to A squared minus B squared, where C is the distance between the center and the foci. And we can see that C, to get from the center to the foci, is 2. So what we can do is we can fill in the values for C and A and solve for B. So we said C is 2, so 2 squared is 4, is equal to A squared. A we said was 4, so 4 squared is 16, minus B squared. So if we add B squared to both sides and subtract 4 from each side, we'll get B squared is equal to 16 minus 4 is 12. So now we have everything that we need to write the final equation of this ellipse. So we have x minus h squared, so x minus h we said was 0, so 0 squared, over a squared. A we said was 4, so a squared is 16, plus y minus k. K we said was 0, so 0 squared, over b squared. And we just figured out that b squared is 12, is equal to 1. So we can write our final answer as x minus 0, that's just x. So we have x squared over 16, plus y minus 0 is y, so y squared over 12 is equal to 1. And that will be our final answer. That's the equation of this ellipse. All right, let's try one more example. Let's say we're told that the foci are located at 0, 8 and 0, negative 8, and the major axis has a length of 20. So if we sketch this situation, we can see the foci are at 0, 8. So let's say this is 0, 8. And 0, negative 8. So let's say that's somewhere down here. 0, negative 8. These are the foci. So we can see that this ellipse is going to be vertical. So now we need to figure out what is h and what is k. Or in other words, what is the center of this ellipse? Well, the center is directly in between the two foci, which we could see, and this one is going to be at 0, 0. So the center is 0, 0. And remember, these are equal to the coordinates h comma k in our equation. So now we need to figure out what is a squared and what is b squared. Well, a squared is the distance from the center to each vertex. So the center all the way out to the vertex, that's a. And the center to this vertex is also going to be a. Now we are told that the major axis length, or in other words, the entire distance from one vertex to the other, is equal to 20. So that means the distance of A would just be half of this length. Or in other words, A is equal to 10. So to go from the center to this vertex, we have to add 10. And to go from the center to this vertex, we would have to subtract 10. So we have A is equal to 10. And remember, B is the distance between the center and the covertices. So here's one covertice, and here's the other one. But we don't know what B is, but we do know that the following relationship exists. C squared is equal to A squared minus B squared, where C is the distance from the center to the foci. So we can see that this distance of C is equal to 8. So we can say C squared, which is 8 squared, is 64, is equal to A squared. A is 10, so A squared is 100, minus B squared. So if we add B squared to this left-hand side and subtract 64 from the right-hand side, we get B squared is equal to 100 minus 64, that's 36. So now we have everything that we need to write our final answer. So we get x minus h squared. H we said was 0, so x minus 0 squared over. Now remember, when we have an ellipse that is vertical like this, the a squared, which is the larger denominator, will always be rewritten under the y term. So actually we're going to write b squared under the x term. So we found that b squared is 36, so we'll have 36. Plus y minus k squared, k is 0, over, and remember we said that a squared will be written under this y term. So a is 10, so 10 squared is 100. And we have all of that equal to 1. So we can simplify that to x squared over 36 plus y squared over 100 is equal to 1. And that will be our final answer.